So here we're looking at what we've done more or less so far this year. Uh, the practice sheet is probably harder than the actual quiz because there will be a couple of the questions that have been turned into multiple choice. This one could be turned into multiple choice. I just don't have enough time to come up with 5 or 6 different graphs and create them so they look nice. So it's going to stay free response. Normally I would do this with tables, but this isn't too hard. And that's worth talking about. I would normally do this with tables. Uh, if there was a horizontal compression, stretch, or vertical compression or stretch, I'd use tables. Because when that happens, things don't look quite like you expect them to look. But it's only a reflection over the y-axis and shifting down. So let's talk about how to reflect over the y-axis. It's really simple. You change signs on x. That's all you really do. I'm going to go through and plot some points and I'll get started. This is at what, negative 5, 3. This guy is at 0, negative 2. This guy is at 2, negative 2. And then this last piece that I want to move right here is at 5, 4. The first thing I'm going to do is reflect over the y-axis. Notice how this is 5 units to the right. When I reflect, I'm going to be 5 units to the left. Let me change colors here. Maybe. Come back here. Come back here. There we go. It's going to be over here. This is 2 units right. Now it's going to be 2 units left. This is 0 units left or right. It's going to be right there. And this is 5 units right. Now it's going to be 5 units left. So I'm going to go through here and do this piece by piece. This is the negative f of x piece. All right. And now down 2. That's as simple as it says. Take what you've already done and shift it down 2. Change over to blue. So down 2, down 2, down 2, and then down 2. This is my final graph. This isn't too hard. This ought to have a pretty good rate of success. But this is the negative f of x minus 2 piece. Like I said, I'd use tables, but there's not a whole lot going on this one, so I'm not going to. And I hope that makes sense. You don't always have to use tables. If it's easy, maybe you don't. Perform the following transformations on f of x equals x squared in the cumulative order. That means that as we do one step, it's changed a little bit. Horizontally stretched by a factor of 3. Now, by the way, your form on these is A, F's, B, parentheses, x minus h, close, close, plus k. A is your vertical stretch or compression. B is your horizontal stretch or compression. And it is opposite of what you think. H is going to be your horizontal shift. Translation maybe in some text. And again, it's opposite of what you think. And K is your vertical shift. If it's on the outside of parentheses, it's vertical. If it's inside, it's horizontal. And if it's inside, it's opposite of what you want it to be. So horizontally stretching by a factor of 3 is actually a third on the inside. Because again, oops, wrong place of parentheses. Square's got to be on the outside. Shifting left does not mean I take away, it means I add. And I've got to introduce another parentheses because it has to be inside again. Then I close, quantity squared. That's lining up with this B down here, that form down here. Vertically compress, I can trust that. and then have a half out front, 1/3 x plus, I don't know why I wrote a third there, that's a 3. Quantity squared, and then finally shifting down, that's your k value. So I'm going to keep everything as I have, and I'm just going to subtract 12 from the outside. And there you go. Let's give her a name. She'll be g of x, k of x, l of x, whatever you want. Just don't call it f of x. And that's it right there. It is a cumulative process. All right, so here we got Fred, and Fred screwed something up. Fred was attempting to reflect the equation f of x equals 2 absolute values of x minus 3 plus 4 over the x-axis. He wrote -2 absolute value of negative x minus 3 plus 4. Describe Fred's error and correct his mistake. So Fred did a couple of things. Here, what he did is he did a vertical reflection. That's close, right? You know, over the x-axis, flips it to the bottom. It's not quite the same, though, as a vertical reflection. Then you got this negative symbol in there, and that is a horizontal reflection. Now, let's talk about the original and what Fred should be doing. A picture is worth 1,000 words. So if we take 2 absolute values of x minus 3 plus 4 and we graph it, it'd be right 3, up 4, and have a slope of 2. What Fred wrote's not the same thing. What Fred wrote looks like this. We know that's not right. It's not. It's even said that it's not right. So we're smart enough to know what is right. What is right is that instead of being 4 above, I would be 4 below. And instead of opening up, I would open down, because we should know how to visually reflect. This is right. All right? So again, what did Fred's error? What is Fred's error? He vertically and horizontally reflected. Now, to correct his mistake, there's a rule we follow. A vertical reflection the new function, we'll call it something else, g of x, is the negation of the old function. All right, so we take his old function, that one right there, we put a negative symbol in front of it, and then we wrap the whole thing in a set of parentheses. We distribute here and here. We don't distribute inside absolute value, just the stuff outside. It's a common mistake. Kids think they can negate and should negate everything, but they should not. And this is the correct one. And look at what we actually wrote. This is shift right 3, down 4, slope of negative. And there you go. I don't think it's too hard, but then again, I've done it a few times, right? It's just rules. That's all it is rules. I've told this thing 1,000 times to dock top, but it never wants to do it. All right, this one's going to be an issue for some, and I know it. State the domain. As this particular graph runs left to right, I'm starting at negative infinity. I'm actually running to -1, and I'm thinking, oh, I stop, but the graph is taken over by this piece, and it runs to 3, and I think, oh, there's a jump. It's fine. This piece takes over. So A wrong choice would look like this, and this is wrong. But this will be an answer choice because I'll probably make this multiple choice. It would be negative infinity. It'll take me a minute to type this. Especially when things don't click where they're supposed to click. There we go. Negative infinity all the way to an x value of 1. Union with, now we see an open dot. There'd be a kid who think 1 all the way to 3 with a close. Union with 3 moving on to infinity. Now, because these x values are filled by a function either directly above or a piece either above or below it, I don't need all that. I just need the negative infinity to infinity. We have equality on the same numbers we're saying we don't. Like this one says no equality on 1, but this one says I do. So correct is just negative infinity to infinity. Now, what kind of graph I have on your quiz tomorrow, I couldn't tell you. I hadn't finished it yet. Notice how I have to click the same thing like multiple times. There we go. So there's the correct one, just negative infinity to infinity. The range, what I notice is that this piece right here basically covers the same y value as this piece, so I'm not even going to look at her. But this piece takes care of that piece. Negative infinity all the way to a high value of 2. And the 2 exists. It was solid dot here. It's still solid there. Now, there's a gap, all right? Union with a piece that starts ridiculously close to a y value of 3. And again, range is y, domain is x. And it rises to infinity itself. The zeros, which are your x-intercepts for this function, it's called h of x. We cross here, and we'll kind of have to guesstimate. I would say that's negative 3.5. Good enough for me. I do want order pairs. And then there's another intercept right here. It's at 1, 0. The y-intercept, there's only one y-intercept, and I've drawn over it. But the only y-intercept that I see is right there, and that's at 0, negative 1. There'll be lots of kids who miss these. I don't know why, but it'll happen. State the intervals on which we are increasing. That means we have positive slope. We are increasing on this piece, right up to there, that piece, and this piece. So we're increasing from x values of negative infinity all the way until we hit an x value of 2. We are increasing from negative 1 to 3 as far as x is concerned. And the last x value is where we start increasing, and that 3 should be a bracket. Oh, this is interesting. I about screwed up. I'm talking about x here. I'll show you what I was about to do. I was about to write this, and from 3 to infinity. It's technically right, but I had that overlap there. I can just say forever. Or no, I can't. I'm wrong on that. Forgive me. It needs to stay like this because I don't know what's going on here and I don't know what's going on there. That makes a bit of a difference. All right, state the intervals on which I'm decreasing. Decreasing is going to be my negative slope. The only place that I see decreasing slope is here, where I'm falling. I'm going downhill. And that has x values of negative 2 and negative 1. Parentheses on both. That should be a parentheses, not a bracket. Forgive me for that. And that's in the wrong spot. There we go. Positive means above x-axis. Negative means below. Now let's go back to my graph, clear her up. Positive is going to be here, here, and all of this. I really feel that that can be cleaned up. I don't see why anybody would also not accept -1 to infinity. I can't see a reason why they wouldn't based on what I've seen. I don't think I'm going to show much of a preference on it. I think both are technically right. I think one way is looking at it as a piecewise and one way is not, but I think that can be cleaned up to -1 infinity. Anyways, back to what I'm doing, positive. The x values are, the y values are positive so long as we're stuck between -3/2 and 1, or 3.5 and -1. And from 1 to 3, but they're also positive up here, so from 1 to infinity. Now we have our negativity, which happens in two different spots. Negativity is here and here. So when you talk about your x values, from -infinity all the way to -3, and from an x value of -1 to an x value of 1. Ta-da! And this entire section will all be multiple choice. It will be. You just have to accept the best written way. All right, that entire section is multiple choice because I don't want to have to sit here and infer what kids are thinking. This one will probably look a little different on the quiz. I'll probably give you a graph and say, what is the rule? That's probably how I'll do it. I'll probably make it multiple choice to some degree. But if you can graph a piecewise function, surely you can write one based by looking at the graph. All right, so tables. First one will be about this guy, x and 2x minus 1, which is a line. Think mx plus b. This is a line. This is a parabola, and this is a horizontal line, right? We got a slanted line, a parabola, and a horizontal line. Let's see, we're going to feed this thing 4 and -1, even though I can't be 4. If I feed it a 4, 2 times 4 is 8, take away 1 is 7. If I feed it a -1, it's supposed to be -4. If I feed it a -4, I have -8 minus 1, which is -9. I need to fix that. If I feed it a -1, I would have -2 minus 1, -3. And while I'm thinking about fixing that, I'm going to fix that. That way it's done. All right, so I can plot -4, -9, open hole. I can plot -1, -3. It is closed because of up here. X squared minus 1, I need at least 3 points because I'm drawing a parabola. So I'm going to feed it 0. Do I need 3 points? Actually, I don't. I only need 2. The reason I only need 2 is because if you just thought about this thing, it's been shifted down and drawn. And it's starting at 0. So I just need this side right here. If I plug in a 0, I get -1. If I plug in a 3, I get 8. I'm not allowed to be the 0. So open hole. And if I plug in a 3, I get 8. And that is also open. I got to have a little bit of curvature here because it's a parabola. All right, that's why it looks like that. And then I am a y value of 4 from 3 to 7. So here's where y is 4. I got a nice solid dot there all the way to 7. Interesting. Domain, the lowest x value was -4, and it couldn't be -4. And I had a graph all the way up to -1. And then I have this jump on the x-axis. And I started back at 0, and I had x values, and notice the parentheses because I've opened. I had an x value all the way to 7. Yeah. Range, start down here at -9. Open hole, so parentheses. And I had y values until I hit -3. And that was a solid dot. Then I jumped up to -1. And I continued rising until I hit 7. No. Until I hit 8. Yeah, that was 3, 8. Until I hit 8, and that was open hole. And again, what I'll probably do tomorrow is I'll probably make this multiple choice. I'll probably give you a piecewise graph, and you have to pick out which choice is the best choice. Write the function negative absolute value of x minus 4 minus 5 is a piecewise function. This will probably also likely be multiple choice. We call her f of x because she is f of x. The negative symbol is going to stick around. All right, then we're going to have x minus 4 inside minus 5, which cleans up to be negative x plus 4 minus 5, which cleans up to be negative x minus 1. So let me draw that down here. All right, on the other guy, the negative symbol sticks around, but we change the signs on the stuff inside. Now we do the distributive property, we get x minus 4 minus 5 again, x minus 9. Interesting. So the only thing left to really think about here is domain. So I'm going to go back and I'm going to take a look at the graph because a picture is worth 1,000 words. I go right 4 and down 5. And I have negative slope, so that's what she looks like. And I notice that both x values center around 4, and that's usually true. Maybe you've done a couple of these and caught on, but that h value is the big number here. One side is going to be the left of 4, and one side is going to be the right of it. So the domain's hinging around an x value of 4. This would be the negative slope piece, that piece right there. This is the negative x minus 1. So I'm moving right, so I'm going to be bigger. And this would be the positive slope x minus 9, it's drawn left, less than. One of them has to have equality, it may as well be that one. Moving forward, the last question, which is 4 questions, it's just graphing. All it is graphing. There is an order called Bach, B-H-A-K, but I taught you when you're given an equation how to not worry about it. On this one, we're going to factor out a 3. The reason we do this is because our form AFs of B times x minus h plus k, we only have 1x. We don't have 3 of them. We have 1. We're supposed to graph the mom. Mom is going to be absolute value. And we're supposed to graph the child. The child here is going to be the equation I just came up with. Right 2 up 4. And we have a slope of 3. Ta-da! All right, moving forward with our lives. The next one, you were taught how to eliminate the B term so that you wouldn't have to worry about what it's doing. You wouldn't have to do silly things like make tables, because that's the only way around it. You make tables. So what we're going to do is we're going to distribute that exponent to both pieces, and that drops the need for that master set of parentheses. We still have the negative 8. If you take a half and you square it, you write it twice, multiply it by itself, you get a quarter. And if you take a negative 8 and you divide it by 4, you get negative 2. Mom is, of course, x to the second. Mom is a parabola. And this one should be twice as steep, so it's narrower. And it's going to open downhill after the shifts. But the shift was left 3, fall 5. And she has an initial slope of -2. And she would be steeper, not wider. She's going to be narrower. She gets skinnier. 2 more to go. All right, here we have that 1/3 power. Now, 1/3 power is what we call a cubic root. Now, I know that 4 times 4 times 4 is 64, so it turns out the cubic root of 64 is 4. I can evaluate that piece. Put it out front. And ta-da, she's done. I went from having a B term to an A term. An A term is so much easier to deal with. Our mom function was the square root of x, 0, 0, 1, 1. She also contains 4, 2, because the square root of 4 is 2. There's mom. All right, so what do we have here? The new one is a left 1 down 3. Left 1 down 3 with an initial slope of 4. Ta-da! All right, the last one for this little practice sheet is a square root function. Another square, no, this is first square root function. So here's what I'm going to do. I'm going to pull 16 from both pieces inside. Because I can. 64 is divisible by 16. If you pull a 16 from 16x, you get x. If you pull a 16 from 64, you get 4. Then I'm going to evaluate this. The square root of 16 is 4. It's actually plus or minus if you're solving for x, but for here it's 4. So -4 roots of x minus 4. Notice I dropped the parentheses because I don't need them anymore. They were there just to tell somebody that you had to do the distributive property or vice versa. This is a right 4 up 5 situation. Right 4, opposite sign, trust sign. And we have an, oh, forgot mom, didn't I? Oh, wow. Milbrath. Bad Milbrath. This is wrong. Let's fix that first. Cubic root. Looks like that. Bad teacher moment there. The shifts were the same, left 1 down 3. But we have a slope of 4, so rise 4, run 1. Fall 4, run back 1. Cool, I got that fixed. Bad teacher. All right, back over this one. I had done right 4 up 5. Looks good to me. And I need to draw mom. Mom is a square root, which is what I tried graphing last time. I don't know why I did that. But this one has a slope of -4, so fall 4, run 1. And it looks like that. Sorry I messed up. Good thing is I caught it. It's funny how I work like that. Usually I'll catch something within 2 or 3 problems of doing it wrong and just realize I made the mistake. Because my brain never shuts off, thinks about everything at once. But anyways, there you go. There's your practice sheet. You're welcome. It is an assignment. I think it's worth 8 points maybe.